Welcome everyone to the Ontology Summit 2021. Today is the 10th of February 2021, and I'm very pleased to introduce Todd Schneider, who is giving the first, this is the first session in track A, dealing with the ontological landscape. And Todd will be speaking, or giving his one view of the ontology landscape. Todd?
Thank you, Kenneth, and thank you for putting in that qualification as to the one view, i.e. whose it is. I was going to do that, but thank you. So let's get started. So in terms of considering an ontology landscape, one way to approach it is in terms of this notion of dimensions. And here, these dimensions don't have to be orthogonal, if you're familiar with that notion. You could just consider these as aspects or views or whatever. And certainly this list is not complete. And if you have more things or more dimensions or aspects that you think should be added to the list, please let us know. Ravi and I will compile this list and hopefully provide it to the communique at the end of this summit. So the three items I'm going to touch on today is, what is an ontology and some potential definitions or common definitions that are in use, types of ontologies relative to those definitions, and a whole big, long, ugly list of challenges for developing ontologies. Now, one of the aspects I'm not going to touch on are going to be covered later on. I believe it's in track C, where they're going to talk about automated ontology creation or development. So I'm not going to touch on that. The comments and all of these slides are geared to people actually creating the ontologies in some fashion. So pressing on. Oh, there we go. So here's another view of what the ontology landscape is over time. And again, my perspective, and I believe these summit topics give some perspective of how that landscape or the perception of ontologies and their uses have evolved over time. And of course, at this point, everyone's hot on knowledge graphs, though, of course, those things have existed for some time, as John Soe would argue, i.e. semantic networks and such. All of these, the communiques and all of the associated materials are available on the Ontolog Forum website if you are interested in the details. There's a huge amount of knowledge and information that is across all of these summits. So people can make use of them. And in particular, for the summit from 2013, this one about the evolution across the ontology life cycle, it identifies an outline or a sketch of how you might have a ontology development paradigm. And in fact, there's a group in the Industrial Ontology Foundry that's going to mine that to see if they can devise a common ontology development process for the Industrial Ontology Foundry, the IOF. So why do we want to have ontologies? What is one purpose of them? Well, I claim that ontologies are for communication. And of course, if you have good communication, then you're probably facilitating interoperability. Of course, interoperability is one of the practical uses of an ontology, but that interoperability manifests itself through the ability to communicate. And here, by communication, I mean the ability of a transmitter of a message to have that message interpreted in a fashion that's not too dissimilar from the intended or the transmitter's interpretation. And of course, you'll hear the term interpretation used repeatedly throughout this talk. And I'm taking the notion of interpretation from the Tarskian view. So if ontologies are for communications, let's consider what the types of communication paths there are. So of course, there's people to people, and one of the primary means for communication is natural language. It's not the only one, of course. There's the old physical force interaction too, which can be a problem or useful times. Then we have people to machines, and there's multiple interfaces there. There's natural language, and then there's translated into formal languages, and that translation process can be lossy. Then we have machine to machines, communications among those things. And that's where we get into some interoperability issues technically. And they interface by using formal languages. Again, there are translations involved perhaps, and they could be lossy in those translations going back and forth. And then of course we have people to machines and back to people again. So there are interfaces along the way, both natural language and formal languages. Now I want to claim that an ontology is actually an interface for communication. Now this might be patently obvious, but I don't think it's brought out enough in a lot of the literature and talks. And of course, in terms of communicating, you want to express some information. Though, of course, in talking to many people, that might not seem to be the case. They just sort of like to hear themselves talk. Hopefully, I'm not doing that now. And then one of the things in communication, which is assumed at some point, but really shouldn't be, is that you assume the recipient will share your intended interpretation, or at least their interpretation of what you are telling them, or the information you are conveying is not going to be dissimilar or greatly dissimilar from yourselves. And of course, this assumption is the basis for a lot of comedy, right? But in terms of ontology and communication and providing some information, just listing terms, that is natural language terms or phrases, is insufficient. So there are many things out there that are given the label ontology and may conform to, say, the W3C OWL specification, but they're just a bloody listing of terms and nothing else. And again, there's the implicit assumption by those creators that those terms are sufficient to convey the intended interpretation to other people and to machines, but that doesn't really work. So in order to convey that information in your communication, you really need definitions. So what are the natural language definitions? And those are for humans. And then what are the formal definitions in some particular language, whether it's first order logic, common logic, OWL, something that can be used for computation. And of course, we would expect that the natural language definition and the formal definitions are consistent with each other. Now, it may be the case that the formal definition, depending on the representation language you're using, really can't convey the extent of the natural language definition. And this is where the natural language definitions come in critical when you get to actually applying the ontologies in a particular information system, because you can give the ontology to the developer and they're going to look at the natural language definition, they're going to look at the formal definition and say, there's a gap there. How am I going to mitigate that gap? And they're going to have to look at the natural language definition to get an understanding of what they should do for their mitigation. Now, track B will address more about definitions, and I'll leave it to them to carry on. So back to what is an ontology? Well, I gave you what a purpose is. So here's a definition from Nicola Guarino. That is, an ontology makes explicit people's distinctions and assumptions about the nature and structure of some portion of the world. And then a particular computational ontology is an engineered artifact, again, representing an intended interpretation of a vocabulary in a machine-readable form, distinguishing and describing the nature and structure of some domain of discourse. Now, this part about being an engineered artifact is something that is also might be taken implicitly, but if you take it explicitly, then you can say or ask, what engineering practices should I be using in developing an ontology? So on to the types of ontology. Well, I'm only going to identify 4 types, and those types are listed down here, and they're based on this notion of what distinguishes them in terms of the number of domains in which they are applicable. Now, there are some further distinctions made about what an ontology is or it is not. You know, whenever you ask what something is, you should ask the negation of that. What is it not? The complement. So based on this notion of the number of models or domains, then there are sort of 4 commonly recognized types of ontologies. There's application ontologies, domain ontologies, reference ontologies, and foundational ontologies. And I'm going to talk a little bit about each of those. And if you disagree with any of those definitions, please put it on the chat and we'll discuss it when I'm done. So a foundational ontology, and they consist of notions And by a notion, I mean not necessarily things that are just considered as nouns or concepts, but also relations, which of course could be considered concepts. So a foundational ontology is just a set of notions that are common across almost all domains. That is, any place where you might want to consider what exists or does not exist and the relationships among those things, the foundational ontology is supposed to be applicable. And they provide just a minimal set of distinctions among entities, but the constructs that they provide and the common semantics are really important to allow the interoperability of more detailed or more constraining ontologies. I'll say a little bit about how you use them later on. I know there's controversy about the value of foundational ontologies. Okay, but in particular, a foundational ontology in its use of minimal distinctions makes very few ontological commitments. Hence, they can be extended as needed. But on the flip side of that is that they allow many models or interpretations of their notions, which is good and bad. And they can be used, or should be used, as a starting point for reference domain and application ontologies. And then they are literally the most difficult things to create and require a heck of a lot of work. So once someone's done all that work, if you think it is of value, you should make use of it. Okay, so the next level is reference ontologies. So they are based on, it can be extended from a foundational ontology, and again, to support interoperability. And a reference ontology provides additional constructs and distinctions for a large set of domains, but perhaps not all domains. And there are about two, possibly more than two types, but I can say there's at least two types of reference ontologies. Ones that focus on a single subject area, but are applicable to many domains. So things like an ontology for time, that's certainly a domain, but it's applicable across lots of others. And the notion of qualities, and then units of measure. And I'm sure there's more that I haven't listed. And then there are those that provide a basis for consistent extension in a particular domain. So for instance, if you're in biology, if you're in physics or engineering, you can have reference ontologies that cover many of the constructs or notions that are used in those particular domains. For instance, you can get even finer if you want to get down to things like sort of maintenance or finance. So that's the reference ontologies. Now, domain and application ontologies, well, they're intended to represent more detail in a specific domain. Obviously, they say domain ontology. And again, if possible, you'd like to extend reference ontologies to provide more constructs or the basis for your domain's ontologies. And then from there, at the most detailed level are the application ontologies. And of course, they're designed for uses in specific applications or information systems. And they have the most number of distinctions, or formal distinctions specifically, and usually they're the least interoperable. Now, one of the things I didn't point out is the degree of interoperability among those types of ontologies, but that should be apparent based on the number of distinctions and their if you like, consistent semantics. Now, one way to view these types of ontologies is in the following diagram. So on the one hand, we have this notion of logical distinctions. And these are, if you like, more clauses in a formal assertion. So if you have very few logical distinctions, those are usually associated with foundational ontologies, it means you're going to have many interpretations. That is, many possible models that would satisfy those logical distinctions. And then as you keep adding more logical distinctions, you're going to get fewer and fewer possible interpretations. Of course, once you get to an application, you don't want to have interpretations that are going to be dissimilar from what you expect or what you need. So in terms of models, an interpretation you can consider as a model. I don't want to say a little more about that right now. Again, this is representing a Tarskian view of things. Now here gets to some amusement. Here's a formula, and here this is the equivalence relation, and this is conjunction, if you like, existential quantification, universal quantification, and implication. So what do you make of that formula as it stands? Anyone? Can you tell me how it should be interpreted? Anyone out there? You can speak up. I can't see the chat right now, so if you want to speak up. Okay, well, how about if I show you this? Here's a formula. Again, that's equivalence, conjunction, existential quantification, universal quantification. I bet you can make a little more sense out of this formula than this formula. But you'll notice structurally, they're exactly the same. So what's changed between these two? Well, I'm using different symbols. But as a human, I can make perfectly good sense of this. Whereas as a human, if I just, as I did, give you just that independent of any context, you say, what the, okay. But what if you're a computer? Can you make a different distinction between that and that, other than the fact you're probably chewing up more memory spaces and the code that you're using are a little different? But from the computer's perspective, these look pretty much the same. Okay, so what are these differences? And more importantly, for whom or for what are there differences among those two formulas? So this leads us into some of the ontology development challenges. Now, I know this slide is really dense with a lot of text on it, so I'm not expecting to go through every one of these terms every one of these challenges right now. It's meant to be read later on when you have more leisure time, if you like. But one of the challenges and problems I see continually in use of, or in the development of ontologies, is the use of natural language terms and phrases as symbols. Again, in developing a computational ontology, perhaps I should have qualified it as that, a computational ontology is being developed in a representation language, which in general, currently, are fragments of first order logic. So in a first order logic, you have symbols, and then you have the interpretation of those symbols. But for simplicity, if you like, or for practicality, the symbols that we use are natural language terms and phrases. But one of the problems in doing that is that once you see a natural language term, and assuming that the language is your native language, you're going to have some implicit bias. And it's really hard many times to identify what they are. And worse than that, you may have asserted or associated with that term or phrase some assumptions or contexts because of the familiarity you have of the use of that term in those contexts. So this is a particular problem when you get subject matter experts. So subject matter experts should never be left in a room to develop an ontology by themselves. And then another, following on from the use of the natural language terms and all of these biases and assumptions that we have with the use of natural language terms, is the understanding of what really needs to be represented. So it may be the case that you have some nice notion, what was the previous slide? Let me go back a second. Oh, okay. So what's a manufacturing tool? Well, the important thing there, for instance, is what is a tool? The context is manufacturing, but the tool is the thing you really should focus on, and then you can consider its use or its role in manufacturing. And then even after you've done all of this work to understand what really needs to be represented, you have to really decompose the notion, the term, and understand the context in which it expects to be used. And you really have to try and remove the context to get to the entity. And again, the entity could be a relation that needs to be represented. You need to develop a useful natural language definition. And this is a challenge. And of course, the first place to start is the Oxford English Dictionary if you're doing things in English. But that's only a starting point, because then there are standards that you could look at. So in particular, the ISO has a website where you can search all the standards for particular terms. And it can be quite amusing to see the fact that there can be literally hundreds, if not thousands, of definitions in the various standards that address the same notion, but have either some differences or substantial differences in how that standard interprets a particular term or phrase. So it can be a challenge to try and figure out what your natural language definition should be for your ontology. Now, if you're doing an application ontology, then you probably already have an idea of what that natural language definition should be, because you want it to conform to the expectations or the requirements in your particular application or information system. And now another problem is avoiding ambiguous or polysemous notions. And by those, oops, that shouldn't be there. I'm sorry, gotta go back. Part is not necessarily, well, actually it is a polysemous notion. It should never be considered as a noun. The part is a role that something plays. So things like the term component, I'm sure many people have heard that. Subsystem, those are just absolutely ambiguous terms and should be banished from consideration when you're building an ontology. Another challenge for people is a lack of understanding of the use of ontological constructs and analysis techniques. So in particular, I mentioned foundational ontologies earlier, and the amount of work that goes into developing those. They have done a lot of the analysis that can provide a starting point in terms of ontology development. So they have some constructs in there that can be quite useful for understanding what needs to be represented or how you should understand an entity before you get to the actual representation. And then, of course, there are analysis techniques that you can use. And that gets to the effective use of foundational ontologies. Another issue that comes into play with people who are just starting off developing ontologies, suppose you intend to use explicitly a foundational ontology. People can get seduced into finding a place in that hierarchy, if you're using, say, OWL, in the hierarchy where your noun entity should be placed without fully understanding what that thing is and what needs to be represented for your to meet your requirements or your expected uses. So one of the observations I have made over the years, if not decades at this point, is not everybody should be considered capable of developing an ontology. Just as you wouldn't let someone who's very expert at developing circuit boards run into a surgery and perform surgery, I don't think everyone is trained adequately or has the background to develop ontologies. Now, a lot of people won't like that, but that's been my experience. The result of their work is usually, well, it might solve a particular very local problem, but it will not be reusable, which is one of my goals, is to produce something that's reusable. Now, among the other challenges are the constraints of the representation languages, of course, especially OWL. Now, it's unfortunate that OWL has such good commercial support because it's really very constraining as opposed to, say, first order logic or common logic. Of course, common logic would be your first choice if there was sufficient commercial support, but there isn't. So, well, hopefully that will change. Another challenge is operational performance issues. So I've got a great ontology. I've represented everything out the wazoo, but in terms of computational time, the resources needed, it's just not working. So many times when you develop an ontology, you have to go back and scale it back to meet the operational requirements or constraints that are put on it. So maybe my query is taking a minute when it really should have only taken 3 seconds or something even less if you're dealing with real-time systems. Another challenge is, as I've sort of alluded to, is this ability or inability to reuse existing ontologies. There are many, many ontologies or many, many things out there that are called ontologies that I would not consider such, but more importantly, they really can't be reused as is. Now, for instance, if you go to the IOF website, Industrial Ontologies, something or other.org, there's technical principles there that identify some of the characteristics that an ontology should possess. Of course, among them are the issues of definitions and other things. But when you go to look at some of the things out there that are called ontologies, you just really can't reuse them as is. Of course, they can be very good for mining for notions. You know, I think Michael Gruninger calls it hijacking, but you really can't use them directly. They can take a lot of work, and the amount of work that may be needed to reuse an existing ontology may be greater than just creating your own from scratch, which sort of doesn't get us along very far in terms of reuse. And as I mentioned already, subject matter experts shouldn't be allowed to exert too much influence in development. They are, of course, subject matter experts, and you want to extract that expertise. But in terms of the actual representation that's needed for a particular application, you really have to be careful because of this issue I mentioned up here about the use of natural language terms and phrases and the biases and assumptions that are implicit in the use of those terms, and especially by those subject matter experts who may have been using those terms for quite a long time and have expectations as to their interpretations. And then, of course, creating interoperable ontologies. So those are just a few of the ontology challenges. I've probably missed some. Again, if you know of more of them that should be on this list, please let me know, or Ravi for that matter. So as I mentioned earlier, I don't think we should expect anyone, Tom, Dick, or Sally, to be out there creating ontologies. Of course, that might depend on what you consider an ontology. However, this is a little diagram that I developed back in 2012, I think at the first IAOA summer school. And these are some of the disciplines that should be considered in the development of ontology, right? Linguistics and vocabulary come into play. The representations and knowledge of logic is very important. The formal ontology or ontological analysis, some of the aspects of conceptual modeling, engineering practices. I think at this point, some of the practices from systems engineering are most applicable directly. So what are your requirements, for instance? And then the application, what are you going to use it for? What's the domain you're going to be representing things in or for? And of course, reasoning. Many ontologies aren't really concerned about the use of reasoning. I myself am. They can save a lot of work because you don't have to represent a lot of things. Your reasoner can do it for you. And now here's an overlooked analysis tool. This might seem, again, patently obvious or stupid on my part to mention it, but when people go to create an ontology, they're looking at a notion, again, usually coming to you as a natural language term or phrase. And in order to understand what needs to be represented, you may not go explicitly through such a list. Now, here are just some potential questions based on these interrogatives. And of course, there are some other interrogatives, but they didn't fall nicely into this little pattern, so I didn't put them in. But in terms of analysis, you don't have to know a lot about identity, theory of identity, or mereology, perhaps, or plurality for that matter. But you can just ask these questions. Everyone should know these interrogatives. And you can ask, what is this entity? What does the entity do? Where does this entity exist, or when does this entity exist? And this one can be very important because many people confuse an entity with a role that some entity has. So for instance, if I say, this is an asset of my company, or this is an asset of this organization, what the heck is that? Is there a class that should be called asset? Well, maybe, but that thing that I'm asserting to be an asset is really a role that entity plays. Similarly, when it comes to the notion of product is quite interesting. That's just a notion that is a role, in fact, that some entity can play for a period of time. But then, of course, with these interrogatives, you should also consider the negatives of these questions. So what is an entity? Okay, what is it not? Because many times, especially using OWL, it may be the case that to assert what something is, what are those distinctions, you have to say, well, what the thing is not. Here's some other overlooked aspects, and some of these will also be addressed in track D. How do you expect your ontology to be used? Now, it is the case that you may develop an ontology, very nice ontology, meeting all the good principles that have been outlined, and you put it out there and you find that people are taking it and using it for things that you didn't expect. Well, that's good. They're reusing it. And another challenge, which isn't usually addressed properly, is how are you going to deal with changes? That is, if you have your ontology, it's being used in an application or an information system, usually that application or information system is going to change over time. So how are you going to handle those changes? And of course, in implementing an ontology in an application or information system, there are going to be some entailments. For instance, queries. I mean, that's one of the primary uses of having an ontology, is to facilitate querying in a consistent, coherent fashion. So if you change your ontology, how do your queries change? So the issue of governance is a real issue, and I don't think it's addressed yet in any well, I don't say useful, but common way. How will your ontologies be sustained? Of course, this is part of governance. What does sustainment entail? What is the architecture of your ontologies? Now, if you're building ontology or ontologies for an information system, you're probably not going to have a single one. There's probably going to have to be several of them. They're going to be related. How are they related? How are you going to modularize your ontologies to facilitate reuse as their implementation in your information system or your application changes over time? What's the architecture into which they're going to be injected? Right? If you have an enterprise information system, you have 5, 10,000, 50,000 or more people using the various information systems. How are you going to make that transition from, say, relational database or fixed schema, whatever, into some more dynamic capability provided by ontologies? This is not something that's discussed very often, at least in the ontology community, unfortunately. And then, of course, the old standard one, where's the money going to come from? Well, you might get some money up front to do a little pilot project, and people may say, oh, yeah, that's real good. Then where does it go? And then even if it is decided to make use of your work, are they going to sustain it over the long haul? Because that then gets back to how the transition will be made, unless you're developing something brand new, which is very rare nowadays. And then what's the architecture into which you're going to transition your ontology? So these are some overlooked aspects. Now, Track D is going to address some of these. And with that, I think I'm done, Kenneth. Okay, so I guess
Thank you very much, Todd.
Okay.
So, yeah, that's great. I think we're going to move on now to the discussion part of the session. And let's see, I'm looking at the chat room.
Leah has a hand up.
And yes, Leah, you're first.
Yeah, I'm sure. I'm the first one who raised my hand. I'm not the first one who asked a question, so I'll go ahead. So during your talk, you mentioned the idea of like not everybody is suitable for leading ontology development, especially when you're working with subject matter experts. And I'm just curious if you could like expound upon that idea a bit. I just kind of trying to find resources and kind of get a handle of like additional work that I need to do to be educated myself in ontologies. I looked back at the 2010 communique, and it basically said, well, you know, education for ontologies is great, but it's really still very formalized in a few university programs. And
yes,
for anybody who wants to do it, like already being trained in one profession and wanting to add that to their skill set, it's still a challenge to get access to those resources. And 10 years later, I would still say that's the case. I mean, there's still probably more resources, but it's still like, I was just kind of looking for myself, like what classes are there? What are like my professional training for the year? Like, you know, my boss is asking me what I want to do. And I'm like, okay, here's some conferences, here's this, like, it's kind of difficult. So I'm just curious if you could speak to that a bit.
Well, it's quite interesting, Leah, because just literally yesterday, I got a question, the exact same question from someone else. That is, they asked specifically, were there any online courses that they could take to learn about ontology development? And I'm not aware of any. So if anyone out there on today's meeting is aware of such an online course, please post the information there now. So the best I could do to help this person out is I pointed them to a textbook by Maria Keat from the University of Cape Town in South Africa. It's a free book. It's open there. You can get it online if you search for Maria Keat, K-E-E-T. Hopefully someone could put the URL for her website there. It's a pretty good book. One of the problems I have with the university courses, and Kenneth, you can berate me now, is that they are usually given by the computer science department, and they focus too much on the computer science part of it and not much, if at all, on the ontology part of it. Now, if you have time to go over to Italy and hang out in Trento with those guys over there, they can give you a more rounded education in that. But in lieu of that, another book that you could consult, at least the first half of it, is the book by Barry Smith and gang. It's called Building Ontologies with Basic Formal Ontology. And I say read the first half because that gives you a good basis. The second half, you have to be careful with BFO or Basic Formal Ontology because they make certain assumptions that you may not agree with. For instance, their assumption about realism. Other than that, I'm really not sure. So if anyone has any good answers for Leah, please let her know. Now, Leah, I sort of grew into this area just because my predilections, that is, I had training in physics as an undergraduate. And then in graduate school, I was in mathematics, but I hung out in the philosophy department a lot. And my area in mathematics was mathematical logic. So my training sort of led me into this direction, in addition to my own semantic confusion, which started early on, say the 3rd grade with symbols. Sorry, I can't give you a better answer.
No worries. I'll just quickly say before we move on, I'm coming from librarianship, and I'm responsible for our agency's taxonomy program. So that's kind of where I'm coming from, and from just what I've seen from other, just in this series, this summit, and then just elsewhere. A lot of people come from either the hard sciences, mathematics, or philosophy, and there aren't many people coming from kind of the librarianship information science realm, at least from what I can tell. So that's also something I've kind of faced, with your, computer science focus versus ontology focus. That's what I've come across, trying to just
Funny you should mention librarianship. Actually, my training was philosophy.
Hold on, who's speaking?
Right. This is David Hay speaking.
Hold on, David, before you go on. Well, Leah, I think you are well positioned to go into this because library science requires a lot of the analysis, or some of the analysis that you needed for ontology development. But you have to also recall that the notion of ontology goes back several thousand years. And what we're doing for the last 20, 30, maybe 40 years are computational ontologies. So there is a difference. And this is where the issue of logic and computer science comes in. So David, I'm sorry.
Yes, I'm a great fan of the liberal arts education. And it's much more useful than a computer science education in all of this. But you might be amused if you go to the Library of Congress, loc.gov, and look up data model patterns. This is a presentation I gave at the Library of Congress, and it's specifically about what I grew up doing, data models, and then later discovered, I'm doing ontologies. Because the data modeling is exactly the subjects that you brought up this week, and the difficulties of doing it, and the way to organize it are that. I do foundational models, and what you're calling this foundational models, which came from doing a lot of specific data models for various clients and discovering, these are all sort of the same or sort of similar, and identifying patterns, and discover that I can use the same structure, for different companies. And so learning how to do that made me much more successful than people coming and think of as database designs. So yeah, coming from library, you're in a good, in a good starting place.
And as Laura just pointed out, the IAOA is planning a new series of online short courses. Excellent. Now, there's also another resource that might amuse you, Leah. There's a term list that I actually started back in 2012, and I could, maybe I can find the URL somewhere. It's sort of hidden. It's part of the education committee of the IAOA. They have a separate wiki site, and there's a term list there, and you could peruse some of those terms to give you an idea of some of the notions that are involved in developing ontology. So for instance, a continuant, an endurant, or a predurant, an occurrent, some simple distinctions that can be made.
So,
Okay.
this is Andrea.
Hi, Andrea.
Todd, I kind of disagree on BFO and its value. Anyway, Leah, if you looked at what I wrote in the job description for general skills, I've written a bunch of job descriptions for different groups. I think I agree with Dave definitely about liberal arts and having a background. But the thing that I think was most helpful to me was to look at the general systems thinking, to take a general systems thinking approach to problems, which is determining the boundaries, determining the components, thinking in terms of systems. Can you look at a few trees and abstract the forest? Or can you look at a forest and figure out what's important about the trees, kind of thing? It's about communication and abstraction and analogies, commonalities. I think it's very different than just saying that you're going to look at BFO and figure out what's important about a problem. The reason to create an ontology is to address a problem, I think. And I have found that the more useful ontologies were actually written by people who then turned around and had to use their own ontologies and had to actually deal with where there might be ambiguities in what they've said and deal with, I've created this really complex thing. It describes everything exactly, but it's so complex that when somebody looks at it, they're going to go, hell no, I can't use that. I'm not even going to bother with all these reifications and everything you've put in place. And so that's why there's this kind of specific experience too. And it doesn't have to be programming. It has to be just creating examples that use the ontology to describe what it's supposed to be doing, like, to address your competency questions. So I kind of have a little bit different take on this.
Well, Andrea, I do want to address this issue of foundational ontologies and their use, but I certainly agree with you that systems engineering, that perspective is very useful and perhaps the best of the engineering disciplines out there that are applicable directly to ontology development. Now, the issue of foundational ontologies, I can understand why many people don't want to use them, but then the question becomes, how do you use them? In that, if you're working in OWL, you could import them directly and be forced to use their hierarchy. The other situation, or another situation, is that you can look at their constructs and understand their distinctions and see if those distinctions are useful in your analysis to understand an entity when you go to represent it. Now, if people are having problems with the notion between a continuant and a current, or generically dependent continuant, if they can't understand those notions, I think it's a problem. Not that they have to use them, but the basis for those notions, I think, should be understood by the people that are claiming to be developing an ontology. So especially when you get to dependence, for something to exist, does something else have to exist?
And
Andrew?
I would agree with you to some extent.
Okay, I'll take
and
it.
It really depends on what the problem you're trying to solve.
Oh, yes,
is.
yes.
And so I don't disagree with you at a high level. I kind of disagree with you a bit on the, pick and choose, be informed, but actually, everything in that discussion really is systems design thinking too.
Yep.
General systems thinking. And so do you have to understand the bizarre philosophical term? This is my opinion.
Oh, it's
That's
entertaining.
listed
Come
in
on.
BFO. No. Do you
No.
have to try to read how that's written? No. Do you have to subclass? And you already said no
Yeah.
to that.
Not necessarily.
And so I think we agree at that level.
Well, again, there's another point. It has to do with the time frame in which you expect the thing you're developing to be useful. If you expect it to be just a quick thing, sure, you can do anything under the sun as long as it gets the job done. If you're developing something that's feedback. Ooh, I love it. Delayed echo. If you're developing something that's going to be used in an enterprise information system, you really have to have more thought to it. And in that case, the longevity of the use of that ontology, I think necessarily requires a little more thought up front. Just as in any systems engineering situation, you know, if you're developing a probe to go to Mars, you're going to take a little thought on how your power supply is going to be developed, as opposed to just getting a battery off the shelf and hopefully it works for the duration of the mission.
Oh, I'm not arguing with you about that.
Okay.
That we agree with. And
Yeah.
and I am actually not even talking about the I need a quick and dirty model to do something kind of thing. I'm more thinking about what are my use cases and then actually creating an ontology and what are the things you need to worry about. And so if you're using BFO as a guideline of things to worry about, yeah, you know, because that's what systems thinking is all about too. What are the boundaries?
Yep.
What are the things? What are the things you need to worry about? What are the things you can ignore? You certainly don't want to model the world in all of its complexity, because then you're never done. And if you did that, you don't need a model. You don't need an abstraction if you can't abstract.
Yeah, but some of the simple constructs are usually overlooked, and I think I mentioned one of them, the notion of a role. The notion of a role is very important, but it's not used to the extent it should be. Things are confused, and it has to do with the time duration in which the entity has that role. One of the problems that's overlooked also in ontology development is that when you assert something is or can be an instance of a class, if you don't have any time constraints that you're then asserting for all time, this thing always has that type. So the issue of how long an entity could have certain characteristics or certain distinctions can be overlooked, which again gets back to whether you've done adequate analysis, or maybe again that distinction is not needed or that analysis is not needed for your requirements. It depends.
It does depend, and time scale really does depend too. And that's why I find this, you know, continuant and occurrent very problematic, that my continuant in history, even in years, is not you know, or in a current in history, you know, which is in years, is probably a continuant, is definitely a continuant in computer time of nanoseconds, right? So
Yes.
thinking of time frames and saying I have to think about time, I have to think about space, I have to do the who, what, where, when, why, kind of how do I need to answer those questions? I think that's important, but you know, a fiat boundary, maybe. I mean, you know, there's just a lot of things that you have to kind of figure out. And then if you ask people to think about the problems in a very deep philosophical sense, you very rapidly get into philosophy discussions of which there is no right answer. And that's kind of useless.
But this is where the engineering aspect comes in. To some extent, you just have to say, okay, that's good enough. Let's move on.
So this is Gary. Just wanted to make a connection to last year's topic, because knowledge graphs, information about people, as an example, they have roles for a certain period of time. So there's a president for a certain period of time, but that entity that was president goes on and had a prior history and a future history. So to make knowledge graphs actually work, you've got to have an ontology behind it that recognizes those distinctions.
Yeah, but the notion of president, well, the notion of president exists throughout for a long period of time. The people who have that role change over time. So you need the notion of a presidential role.
That's what I said.
Oh, okay.
They have a history of, as a person that goes beyond. You may want to distinguish their history as as an adolescent, a pre-adult phase too. You can make all kinds of distinctions, but knowledge graphs need those distinctions.
Yeah, that's where you get into phase sortals, but we don't want to talk about that here. Okay, Kenneth, are there other questions? Oh, Ravi has his hand up.
Yeah, Ravi, you had a number of questions.
Ravi?
I'm trying to unmute him.
Oh,
I'm sorry, I was muted. Excellent presentation, Todd. Can you hear me now?
yes. Thank you, Ravi.
Okay. I had the privilege of looking at Todd's slides before even he presented because I'm track co-champ, but some thoughts came only while listening to him because by speaking on them, he clarified a lot of things and also raised some questions. Among the burning one for me is the role of the subject matter expert. To me, it is important even to construct vocabulary of the domain and the meaning of those terms. We need subject matter experts.
Oh,
So,
yes.
why were you, or did I misunderstand that you were saying they should be put aside a little bit?
No, no, no. I think what I was trying to say is that they shouldn't be left alone to create an ontology.
Oh, okay.
They have the knowledge, and the challenge for the ontology developer is to extract that knowledge that's needed to develop the ontology so that the ontology meets the requirements of its expected uses. Now, I've been through this exercise more than once, and it can be a challenge to extract from that subject matter expert their knowledge that you need to know as the developer to represent what's needed to meet the requirements.
Very, very true. Remember our history of software development,
Do I
where the
have to?
programmers at one time just said, "Oh, I have understood what you want," and they started providing applications and solutions. It turned out that they were a little bit far away from what the experts needed.
Yeah.
So same thing. It is really a teamwork and collaboration between these two types of roles, SME and software ontology developers at core, whether they use software or other logic elements to extract the ontology. So it's the collaboration extent that will determine that. Then I have some other questions in the chat board, and I am asking them in generic sense that if an ontology is reusable, and let's say we will stick to either domain or applications,
Mhm.
does it mean it is already well harmonized? Or if an ontology is able to be drilled down as an extension, say from some kind of biome to deeper genetics, um, is it better harmonized? What are the kind of thinking in this landscape of the four types of ontology that you described that will give a better outcome of future? Extensibility, reusability,
Well,
interoperation, and so on.
the answer in general to all of those questions is it depends. So that someone might come along and look at the suite ontologies, those things they call ontologies, and say, "Oh man, yeah, those are great. I can use them straight away. Here I'm going to go to town and work with them." Someone else may come along with their context and their requirements or in use cases and say, "No, no, I really can't use those." So whether something is reusable or whether it is harmonious enough is context dependent.
Mhm.
So
Thank you.
I don't know if I can say anything useful more than that.
No, that's pretty good. You may have to, in specific case like suite, you may have to transform even your coordinate systems depending on what space of space you are working in, planetary or
Mhm.
interstellar and so on.
Yeah, understand.
Thank you.
So yeah, I have an experience once with asking a subject matter experts to develop the data model, and they came back with a table with over 300 fields. That was their ontology.
My God.
I mean, that's the problem with asking a subject matter expert, is that they have a little knowledge about data modeling, and that can be a dangerous thing.
Well,
Okay.
that means that the ontology developer's task has become more complex because they don't have a SME helping them build those relationships. There are only entities listed. So you are right.
The point is you really have to have a good collaboration with
Yes.
both
Yep.
kinds of people, subject matter experts and experienced ontology developers.
Yeah, I would make a distinction. I think I did this in the last, the launch, that in between people who understand the data and people who understand, say, how to represent something in OWL, is a conceptual area, a sort of a joint area where the main people can understand the conceptual model and how things are related, and an ontologist can work with that to formalize things, but usually in conversation. So there are at least 3, maybe even 4 types of skills that people need to be able to make a an ontology from data.
Oh, well, perhaps some of that will be addressed by track C in terms of the machine capabilities that could be employed as an adjunct to humans in developing ontologies.
Yeah, I think in between, John Sauer will probably make a little points about the need for communication and conversation about these things. That an automated system can sort of point to a human about where attention might be focused, but domain people have to sort of then look at that and come up with an understanding.
Mm-hmm. So, I mean, in terms of dealing with subject matter experts, it's very similar to requirements elicitation. I don't know if
Yes.
anyone on the call has done that. You go to some stakeholders, they want blah, 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 and you sort of have to ask in more details, drilling down, because they have certain expectations that haven't been voiced in their more general statements.
Yes.
Trying to dig out that detail can be a challenge.
Yes, some tools have made some attempt in mammoth projects at use case generations and related storyboards and so on for rapid development. But similar thing I have not seen in ontology.
Well, we'll get there
Very
eventually.
good. Excellent.
So we're at the
Thank
top
you.
of the hour. I need to point out that there's one difference between the slides I showed today and the slides that are available on the Summit webpage. It's the color of the triangles. For some reason, when I tried to create, or when I did create the PDF file from the PowerPoint slides, PowerPoint didn't like the color blue. So I had to change it to a different color so it would actually translate into something that's legible in PDF. So sorry about that, because I really don't like the color too much that's in the PDF slides. But keep these dates in mind. Mike Bennett is going to talk about the landscape of ontologies from the point of view of conceptual models. Claudio Mazzullo is going to talk about his experiences, or their experiences from this lab in using Dolce for creating ontologies. And Mike Oshold is going to talk about his experiences from the practical end of actually building ontologies for organizations. These are usually large organizations too. So thank you very much for everyone coming. Thank you, Kenneth.
And next week, we're going to be moving on to track B. And in track B, here we have, perhaps Gary, you could give a brief.
Yes, this is still a little bit, I apologize for this, a little bit in the formation stage, because several of the people who have been invited have pressing demands from some of their other real work, including work with the UN. So Pierre, I was in contact with him yesterday, is intending to present, but he does not control some meetings that called by the UN group that he's part of. Also, the same is true for Kai Blumberg. There are other people who I can invite, although the focus moves around a little bit. But the intent is to discuss some work that's been ongoing for a couple of years, as I described last time, on harmonizing domain vocabularies, particularly in the cryosphere realm, ice glaciers, with existing ontologies in the earth sciences. SWEET has been mentioned, but most of the work has been on ENVO, environmental ontology, that will be part of the briefing. One of us will give a briefing on ENVO, and I think that will be useful because you'll see a pretty extensive and fairly formalized ontology within the OBO Foundry work, and therefore it has a lot of relations with other ontologies in OBO, that continues to mature and tries to import useful definitions into areas which were originally populated with ideas maybe from Wikipedia. Some of the early ontologies just took Wikipedia and Wikidata, whatever, as a starting point. And now we are going back to domain people to get a much better sense. And in the process, and Selja is on here, would love to have had a person like Selja present at the beginning, a discussion of what goes into a quality definition. We'll talk a little bit about that. We don't necessarily have all the things that Selja might have been able to add, but she'll be presenting later on, so we'll catch up. The success of this work in the cryosphere is being used to move into other areas. And so if Pierre presents, he'll talk about how ENVO is maintained and how it actually is expanding into areas of interest like the marine sciences. So that's an introduction, and tune in next week to find out exactly who's able to present on this.
Wonderful.
Great. Thank you, Gary. So with that, we will be adjourning. And a quick note, next week, it's going to be a 1.5 hour session because we have a panel. So please make a note of it. And in general, please, mark your calendars. Every Wednesday at noon Eastern time, we're going to be continuing the summit.
Okay, Ken, if I can add another word about that panel. The idea here was that 4 or 5 of us actually presented at a recent conference on this topic, and we had 90 minutes. And so this was planned not as a replication of that, but an opportunity for some of the principal people to have a discussion, to a follow-on to what was actually done at that last meeting. Depending on who comes, we'll be able to have that or not.
Gary,
But that was the intent. Yes, Todd.
in that panel, are any of the members or yourself for that matter going to bring up the ISO specification about definitions? The number escapes me right now.
No. That Pierre may discuss that, but no, that's not necessarily. There's enough to talk about where we are as opposed to those type of things.
Okay.
John Sower talks about the limitations of ISO all the time, so I'm sure he'll talk about it.
Well, I don't know if he mentions that one specific standard, but I'll try and find the identifier for it. Thank you.
You can probably poke Selja to talk about that when she's presenting in a couple of weeks.
Oh, okay. Thank you.
Okay, thanks everyone. We're running a little late. Appreciate everybody participating, and glad to see that everyone is actively participating, and I hope that you can continue to participate in the upcoming summit sessions.